Hello everyone and welcome to this talk. My name is Hassan Hosravi and I'm a senior lecturer at the University of Queensland in Australia. My sincere apologies for not being able to present this talk in person. The title of our talk is Development and Adoption of an Adaptive Learning System, Reflections and Lessons Learned. And this is joint work with colleagues Shazia Sadiq and Dragan Gasovic. Here's a quick overview of the presentation. Educators continue to face significant challenges in providing high-quality post-secondary instruction in large online or on-campus classes. A significant portion of these challenges emerge from high levels of diversity in learners' academic ability. Teach-to-the-middle instruction is most commonly used as it benefits the majority of the students. However, this method does not really meet the needs of learners who differ significantly from the norm of the class. Adaptive systems provide a potential solution to this problem. They require large repositories of learning resources, however, which makes them generally expensive to purchase and develop, making it challenging to adopt them in higher education. To address this problem, we've taken a crowdsourcing approach and have created an open access system called Ripple, which engages students as partners in creating, moderating, and evaluating learning resources that are adaptively served. We share our reflections and lessons learned from developing and piloting Ripple. While our focus has been on developing an adaptive learning system, many of the lessons learned are also applicable to development and adoption of a broad range of educational technologies and tools. So I'm going to start by quickly talking about adaptive learning systems, then about developing cost-effective adaptive learning systems, then quickly introducing the Ripple platform, reflections and lessons learned, and finishing with some concluding remarks. Adaptive learning systems make use of data about students, learning processes, and learning products to provide an efficient, effective, and customized learning experience for students by dynamically adapting learning material to suit their individual needs. They usually have four main components. There's a domain model, which keeps track of the topics that are going to be covered within a course. A content repository, which is a repository of resources that can be recommended to students. A learner model, which estimates the knowledge state of each learner based on the domain model. And an adaptation agent that recommends learning resources to students based on their current learning model. There's a growing body of evidence from 30 years of research from intelligent tutoring systems and educational data mining communities about the effectiveness of adaptive learning systems. Here are a few examples. Some are meta-analysis positioning the effect size of adaptive learning systems based on Cohen's d around 0.7. which is considered medium to large effect size. Adaptive learning systems are commonly designed and developed with pre-existing learning resources and activities targeted towards a particular domain. Pearson, MyLab, McGraw-Hill, LearnSmart, and Alex are established examples of this model. There's been relative success in K-12 where content is standardized. However, given that this model is expensive to use, there's been little adoption in higher education. An alternative platform is the platform model, which provides a content-agnostic system infrastructure that enables instructors to develop content themselves. Smart Sparrow, Designer to Learn, and edX incorporate adaptive functionalities. And this introduces essentially, the instructor team would have to create all the resources using this model, which introduces a significant overhead for instructors. It's been approximated that 25 hours of an expert's time is required to develop 1 hour of adaptive instruction. This makes both types of adaptive learning systems very expensive to develop, purchase, and challenging to scale across different domains. So what can we do in order to develop more cost-effective adaptive learning systems? Hefferman et al. In a paper published in 2016 suggested that crowdsourcing might be used in development of adaptive learning systems, which got us interested in developing our platform, Ripple. There are many examples of successful crowdsourcing applications with different focuses. Wikipedia crowdsources knowledge. Waze crowdsources information related to driving, traffic directions, and alerts. Stack Overflow crowdsources answers to questions that require technical background. Uber crowdsources driving services. Amazon Mechanical Turk crowdsources microtasks. And Patreon crowdsources funding or crowdfunding. There are also successful examples of crowdsourcing in education, which are generally referred to as learner sourcing. A good example is the popular Peerwise platform, which is well known at the 6C community. It crowdsources learning resources. Piazza, or any discussion forum, can be used to crowdsource answers to questions that students may have. There are many peer grading and feedback systems in place that crowdsource marking and providing personalized feedback. Another interesting example is Crowdy, which crowdsources creation of summaries of videos as a set of bullet points. Okay, so let's talk about Ripple. Ripple at its core is an adaptive learning system where the resources are co-created with the students. Essentially, it would allow students to create content, like this example that we're going through. And once they submit the resource, students are also able to help us moderate the resources. Given that some of the questions may be incorrect or inaccurate, we take the students also through the moderation where there's a rubric given where they make a decision and they determine their confidence as well in the decision that they're making. Through the resources that have been approved and are sitting within the platform, our system recommends resources so that students can look through some resources. This is an example here, so they think it's B or C, that's wrong, then they think it's A. Once they see it, they can look at the explanation, determine how effective they think it was, and that is it. The platform also has some other parts, including the feature that matches students for peer study sessions, or the ability to run clicker-based think, pair, share examples within the class, which we're not going to focus on in this presentation. The system is free and open access to use, so feel free to go to ripplelearning.org to find out more about how you can use the platform. Currently, it's been used in 30 courses with over 7,000 users. 10,000 resources are being created by these users, and close to 500,000 responses to these resources are given by the students so far. Okay, so I'm going to talk about the reflections and lessons learned now. We did talk about that. The first lesson learned is harness the creativity of your students. Contemporary models of learning have emphasized the importance of encouraging students to take an active role in constructing their knowledge. Walsh et al. Reported a strong correlation between question writing and performance, and Boud et al. Have emphasized the importance of developing evaluative judgment, the ability of students to evaluate the quality of work of themselves and the others in higher education. An interesting question that may arise is that whether students actually have the ability to create high-quality learning resources. There's sufficient evidence, I've included a few examples here, that suggests that students indeed have the capacity to create high-quality learning resources that meet rigorous standards. There's also an argument to be made that students as authors of learning resources may have an advantage over instructors. They can use the knowledge of their past misconceptions to create resources that have less of a chance of suffering from an expert blind spot. Now, unfortunately, despite students' personal belief and strong evidence from learning science literature about the benefits of engaging students in resource creation and moderation, based on our experience, students often require additional incentive mechanisms to engage them with these activities. Some of the aspects that are worked in our example and our experience is frequently reminding students of the benefits of learner sourcing, inclusion of the activity as part of their assessment and bonus mark, availability of gamification aspects that further engages them, and essentially getting them on board and getting them involved in creating something that they would have or would like to have access to. So for example, co-development of sample solutions to questions from past exams, which was something that students were requesting in some of these courses. Okay, 2, provide rich and transparent models of learners. There have been significant recent contributions in the learning analytics and educational data mining communities on the articulation of the importance of providing transparency in modeling learners. Open learner models are learner models that are externalized and made accessible to students or other stakeholders, such as instructors, often through visualization. The example we see here is the open learner model, which is used as part of Ripple. And based on students' responses to our surveys, they have helped with interpretation, making it easier to understand and interpret why recommendations are made. Easier to understand the rationale behind a recommendation, increasing trust in the recommendations provided, and increasing motivation to study or further use the platform by the students. Okay, number 3, put instructors in charge. It's increasingly being recognized that educational tools and technologies are not aimed at replacing instructors, but are rather used as support tools to enable instructors to improve their teaching practices. We've developed Ripple with the general principle of providing instructors flexibility of how or why they would like to use the platform. We've also adopted co-creation strategies in which we've developed the features of the platform in partnership with the students as well as the instructors. Providing small workshops. So essentially, it's important to provide instructors with the required support for adopting the tools. For our experience here, it has been including in-person workshops as well as online self-serving support, such as a help center that they can use on their own. And one of our design principles has been to consider instructors as the data custodians of the offering that they are running. As such, we've included a comprehensive set of reports that provide rich analytics on students and their learning process and activities. Okay, supporting ethical, low-cost, empirical educational research. While there's been a significant rise in the adoption of educational technologies in higher education, in most cases these systems are built without the aim of supporting research. Consequently, they often do not enable data harvesting or implementation of observation of controlled experiments. So we've developed guidelines referring to consent, transparency, and benevolence, many of which are borrowed from the learning analytics literature, to inform instructors and researchers on best practices of using Ripple towards research. We've then provided access to rich analytics to support observational studies, develop mechanisms for instructors to run quasi-experiments, and to use matching systems like propensity score matching for the two groups that they have, as well as developing mechanisms for instructors to run controlled experiments. Provide mechanisms to motivate students to be actively engaged. There's general consensus that motivation is regarded as one of the most important factors leading to academic success. Ripple uses a variety of systems, including leaderboards, awards, and rating systems, which, as per the surveys that we've conducted, have all been helping students in being more actively engaged with the platform. And finally, do not underestimate the importance of usability, flexibility, and scalability. While consideration of learning theories and pedagogical approaches are extremely important in developing adaptive learning systems and more broadly educational tools and technologies, they're not on their own sufficient for ensuring engagement from students or adoption in educational resources. For usability, we've used a variety of methods with the aim of improving the usability of the system. The following have been most successful. Observing new users interacting with the system allowed us to see how users may be misusing some of the features based on our intentions. Holding focus groups with students and instructors have allowed us to better align the needs of the stakeholders with what the system provides. Addition of feedback and surveys within the platform has allowed us to capture more feedback from the stakeholders. And adding Google Analytics to capture users' interactions and behavior have allowed us to better understand what features are being mostly used so that we can prioritize development with the actual use from the system. Flexibility. There's an increasing demand for educational tools to have the flexibility to be integrated with enterprise systems. While this was a huge development investment for us, we implemented 2 versions of the system. a standalone version, and a second version that uses LTI standard for integration into learning management systems. This decision enabled us to integrate Ripple into Blackboard at our institute to make it more convenient for adoption, while also having the opportunity to invite instructors from other universities to pilot Ripple without getting their university central ITs involved. And finally, scalability. So to keep the cost down, we started by hosting things locally within our own university. We were running stress tests to have a good indication of how many concurrent users or concurrent classes can be using the platform. And it's also important to keep and maintain the system to be cloud ready so that you can move it over to any cloud provider at any time as required. Okay, so concluding remarks. To conclude, educational technologies can help with delivering learner-centered learning at scale. We've developed a tool and shared reflections and lessons learned from development and adoption of our tool. We hope that the lessons we've learned while developing and piloting Ripple can provide insights for other instructors that are interested in adopting adaptive learning systems or involved in the implementation of educational tools and technologies. Thank you very much for your time and attention. I do apologize again for not being able to present this in person. However, I would very much welcome, and we would be grateful if there were any questions or comments to send them to me via email h.khosravi@uq.edu.au. Thanks again.